Here we're going to prove this statement that if the magnitude of r of t is equal to c, a constant, then r prime of t is orthogonal to r of t for all values of t. Show sounds like we're going to prove something, so I'm writing it as a proof. If it's the case that the magnitude of r of t is a constant, then the magnitude of r of t squared by properties of the dot product would be r of t dot r of t. But if we already said that magnitude of r of t is a constant c, then that dot product is c squared. That would imply that the derivative with respect to t of r of t in magnitude squared would be the derivative with respect to t of c squared, which is 0. But if we look at it from the dot product perspective, the derivative with respect to t of r of t dot r of t is going to use the product rule. And so r prime of t dot r of t plus r of t dot r prime of t. Since the dot product is commutative, this is actually 2 of the same thing. So this is equal to 2 times r of t dot r prime of t. Equating the first result, that is that 0 is the derivative with respect to t of the magnitude of r of t squared, with the second result, which is the derivative with respect to t of r of t dot r of t is equal to 2 r of t dot r prime of t, it follows that 0 is equal to twice the dot product. Then r of t dot r prime of t is equal to 0, which implies that r of t is orthogonal to r prime of t. Now this is a result that we're going to use in a later section, but for right now, let's consider r of t is equal to a cosine of t, a sine of t. The magnitude of r of t, you can verify, is equal to a, or I should say the absolute value of a. We don't know if a is positive or negative, but anyway, it's a constant. We also know that a cosine of t, a sine of t is a parametric representation of a circle of radius a centered at the origin. And what we've just shown is that for a vector that forms the circle here, r of t, let's give it a direction here too. There we go. If that's our vector r of t, then what we've just shown is that the tangent vector is orthogonal. This is then a quick proof that the tangent to a circle is perpendicular to a radial line.